Hello everyone, welcome to Jagannath Mathematics Tutorials. So today we will be dealing with the functions, lecture 2. If you haven't watched the lecture 1, click on the iTip, you will be able to see the first lecture. Right? So let's begin. Now, there comes a question, find the domain and range of this function fx equals to 3 upon 2 minus x square. So whenever we are dealing with the domain consists of all the real numbers for which the denominator is not equal to 0, right? So for that we set the denominator equal to 0 to find the excluded values. So if we put the denominator as 0, so 2 minus x square is 0, that means x square will be 2, so x will be plus minus square root 2. Therefore x can take any real value except minus 2 and 2, and for this we can write it as that x belongs to R except minus root 2 and plus root 2, right? So this will be the domain, right? Now how to find the range? So for finding the range we can put y equals to fx and solve x in terms of y, right? So x should be a function of y. Let's see. So y is equal to this, that is given to us, and if we cross multiply, so y times 2x square is equals to 3, then we should simplify it and we will be able to get that x square equals to 2y minus 3 upon y. Now this x square is always positive, right? Which means 2y minus 3 upon y is always greater than or equal to 0. Now, what can be the critical points? The critical points will be y is 0 and y is 3 by 2, right? Yes. So now, if we plot the critical points, you can see here. So if we draw a straight line, and we can see that it is 0 and it is 3 by 2, right? But we want the positive values, right? So it is greater than equal to, we will circle it. So plus minus plus, so y can take any values from minus infinity to 0 union 3 by 2 to infinity, right? So this is the range of fx. So I believe this is clear. So using the concept of domain and range, we can easily find out for any type of problems, right? So now in today's class we will learn about the domain and range of standard functions, right? Like sin x, cos x, log x, and we will also discuss the types of functions, right? Types of functions and their examples. If you are new to my channel, please like, share and subscribe to this channel. So let's begin. So the first type you should know is what's even function. Even function you should know. Okay. Let fx be a function, okay, such that f of minus x equals to f of x. Then fx is called even function. Now, what does this mean? Let's see. That suppose I consider one example that fx equals to x square. So if I take f of minus x, so that will be minus x whole square, which is again x square. which is same as fx. So if this condition is satisfied that f of minus x equals to fx, then the function is said to be an even function, right? This is called an even function. Yes. So let's see its graph. So you can see that the even functions are always symmetric about the y-axis. We can take fx equals to cos x. You can see the graph, it is symmetric about the y-axis, right? And you can also check that f of minus x will be cos of minus x, and we all know that cos of minus x equals to cos x, right? So this is same as the function fx. So that's why cos x is an even function, right? Similarly, we have just seen for fx equals to x square, so f of minus x equals to fx. So that's why the x square is an even function, right? Similarly, we can check for this. If you put f of minus x, then also we will get fx, right? So what are the key factors? First is it is symmetric, right? Symmetric about the y-axis, and one more thing, sum of the even function is also an even function. Sum, difference, right? They will be also even function. Next thing we will discuss is odd function, right? What are odd function? So the condition for the odd function is that f of minus x should be equal to minus of fx. You can see an odd function is symmetric just about the origin, okay, and rotation returns the original function, and the output is negative of fx. You can see the first example, fx equals to sin x, right? So fx equals to sin x. If we put f of minus x, that will be sin of minus x, and we all know that sin of minus x is minus sin x. So from here we can see that f of minus x equals to minus of fx, right? Which means that it is an odd function. Second thing, we can check for the x cube. See, this is symmetric only on the origin, right? So f of minus x, that will be minus x cube, right? Which is same as minus fx. Same we can check for this as well, right? So I hope the concept of even function and odd function is clear to all of us. So what are the key properties? That symmetry, point reflection over the origin, and sum of the only odd powers, right? So if you take odd power, that will always be an odd function, right? Yes. Now here we will discuss the domain and range of standard trigonometric functions, sine, cos and tan. So if fx equals to sine x, so what does the domain means? Domain means the possible input. What can be the possible inputs? As we can see from the graph, all the real numbers are its input. So the domain will be the set of all real numbers. What will be the range? Range means where can it go? So from here you can see, check the range always on the y-axis. You can see here that the graph lies between -1 and 1, right? So the range will be -1 to 1, right? And just now we have seen that it's an odd function. Similarly, you can check for fx equals to cos x. You can see for cos x, that's an even function. Why? Because f of minus x equals to f of x. Second thing, what will be the domain? The domain will be same as the sin x, that will be the set of all real number, and the range will also be the same as it goes from -1 to +1, right? Okay. Next thing, for tan x. Now tan, we all know that tan is undefined for odd multiples of pi by 2, right? Suppose for here, if you try to find out sine pi by tan pi by 2, that is undefined, right? That is undefined. So what will be the domain? The domain will be all the real number except odd multiples of pi by 2. And what will be the range? We can see that it can go anywhere. So the range will be the set of real number, right? Now there comes a concept period. What does period means? Period means, suppose we see periodicity of a function. Suppose I consider a function, let fx is equal to sin x, right? Now what will be fx plus 2 pi? That will be sin x plus 2 pi, right? So sin x plus 2 pi will be sin x only, right? So what does period means? Period means that after a certain time interval, the function repeats itself. When the function repeats itself, the smallest time period we call is period of a function, right? So fx plus t, if it is equal to fx, so this t is called period of a function. So what will be the period of sin x? So the period of sin x will be 2 pi, right? So we can see from here that the period of sin x will be 2 pi. See, same we can say that the period of cos x, that will be also 2 pi, and the period of tan x, that will be pi, right? Because after pi it will repeat itself. You can see this, that after pi it repeats itself. So I believe the fundamental functions, their graph, domain, range, odd function, even function, all these things are clear to all of us, right? Okay, moving ahead. Next, the fundamental functions e raised to the power x and log x. These are very, very important. So if we have the exponential function e raised to the power x, you can see the graph of it, right? So the graph, you can see the domain, it can take any value. So the domain will be all real number. What will be the range? Now range, it will start from the y-axis. So from, so e raised to the power x it is, right? So if you take x as 0, so that will be e raised to the power 0, so 1. So it starts from 1 to infinity, right? Yes. Next is the logarithmic function, that fx equals to log x, and these are the inverse of each other, right? Their inverse function, we will discuss what are inverse functions in our later lectures, right? So for this, it's a vertical asymptote, right? Now what will be the domain? The domain will be from, see, it cannot be 0 because log 0 is undefined, right? So the domain cannot be 0. So you can see that it can take any value except 0. So x should be greater than 0. That is why we wrote domain is from open 0 to infinity, right? Yes. Next, for the range, so again it can take all the values, so the range will be the real numbers, right? Next, square root function and reciprocal function. So the square root function is the unique non-negative real number y such that y square equals to x, and x should be strictly greater than equal to 0. That means This time we can include 0 as well. So what will be the domain? The domain will be closed 0 to infinity. And what will be the range? The range is the same, is 0 to infinity. Now we cannot define the period because the function is not periodic, as it doesn't repeat itself, right? It keeps on growing. Next thing is for 1 by x, the value that when multiplied by x results in a 1 for all x non-zero. So what can be the domain? The domain can be a real number except 0, which we also write like this: minus infinity to 0 union 0 to infinity, right? And same will be the range. For range, always check the y-axis. So again, this function is not periodic, as it does not repeats itself after a particular time interval. Now we will discuss about types of functions. So the very first type is 1-1 function. What does it mean? Let's see. We have defined a function f from x to y. The domain is x, the codomain is y. It is called a 1-1 function if and only if different elements of x have different images in y. What does this mean? It means that if we consider two distinct elements, x1 and x2, so their images should be distinct. It should not be like that if I take x1 and x2, two distinct elements from the domain x, and we should get fx1 and fx2 such that the fx1 is not equal to fx2, right, for all x1, x2 in x. In other words, if these two are same, that means these will be same. Okay, if fx1 equals to fx2, this will imply that x1 equals to x2. This is very, very helpful in proving when a function is 1-1 or not. Okay, you can see the example here. We have taken the set x, which contains the elements a, b, c and d, and we have taken the set y, which contains the elements p, q, r and s. Now we have defined a function f from x to y, which is depicted by this arrow diagram. You can see that different elements of set x have different images in y. No two elements have same image in set y. So from here we can say that the function f is 1-1 function, right? So here f is a 1-1 function because different elements of x have different images in y. Next concept is many-one function. Now if we consider a function f from x to y, it is called a many-one function if and only if two or more elements of x have same image in y. Means it is the opposite of the 1-1 function, right? So in other words, a function from x to y is many-one if and only if it is not 1-1. So if your function is not 1-1, this will mean that the function is many-one. So for example, you can see here that we have considered two sets x and y. X is this set and y is this. We have made the arrow diagrams. So a maps to p, b maps to r, c maps to r. Now the image of b is r and the image of c is r as well, which means different elements of x have same image in y, which means that the function is many-one function, right? Whenever you have such a case where two or more elements of the domain set is mapped to one element in the codomain set, you will say that the function is many-one function, right? Next is onto function. A function from x to y is called onto. It is also called surjective function if and only if each and every element of y is the image of at least one element of x. That is, the condition is the codomain of f should be equals to the range of y. What does this mean? Let's see. Suppose I have a function f from x to y. You can see that here 1 maps to a, 2 maps to a, 3 maps to b, 4 maps to c. Now 1 and 2 maps to the same element a. So first thing, that it is a many one function, right? So f is many one function. Next thing, why is this onto? You can check what's the codomain. The codomain is y, and what's the range? The range is also y, right? Which means that each and every element of the codomain has at least one pre-image in set x. So clearly this is an onto function because every element of set y is an image of at least one element of set x. So that is why it's called onto function. Next is into function. Now what is an into function? So we consider a function from x to y. It is called an into function if and only if there exists at least one element in y which is not the image of any element of x. And the condition is this, that the range of f is a subset of codomain of y, of f, right? So you can see here this function, you can see that d is not mapped to any of these elements of x. So here d is not an image of any element of x. That means by definition there exists at least one element in y which is not the image of any element of x. That is why we say that f is into function, right? Or you can say that when is a function into? A function is into if it is not onto. Next is bijective function. So bijective function is basically the combination of 1 1 plus onto function, right? A function f from x to y is called a bijective function if and only if f is both 1 1 and onto. If both the conditions satisfy, then we say that the function is a bijective function, right? Yes. Okay. One important note here is if x and y are finite set, then a function, then a bijective function from f x to y implies that the number of element in set x is same as the number of element in set y. You can see here we have considered a function f from set x to y. So x contains the elements 1, 2, 3, 4, 5, 6. Y contains a, b, c, d, e, f, and it is mapped like this, right? So firstly you can see that different images are there for every element of x, right? Means no two elements have the same image, they are different. First thing, the function is 1 1. Second thing is that for onto you check what's the codomain. The codomain is y and the range is also y. So the codomain is same as the range. So this is the condition for the onto function. So clearly you can see that the function is 1 1 and onto, which means that the function is a bijective function, right? These concepts are very important as they are asked in your board as well, okay? And one more thing, the second note, that is this. So you can see from here that the number of element in set x is 6, which is same as the number of elements in set y, right? Okay. Next is identity function. So let A be a non-empty set, then a function f from set A to itself, means f is a function from the same set, right, defined by fx equals to x for all x in A is called an identity function. So the most famous identity function is fx equals to x, right? So now what does it mean? It means f1 will be 1, f2 will be 2, f3 will be 3, right? f4 will be 4, f5 will be 5 and f6 will be 6. Means each and every element maps to itself. 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4, 5 goes to 5, 6 goes to 6. If you see such a function, it is called identity function. Now, is it a bijective function? Definitely yes. Why? Because f is 1 1 and f is on 2, which means the identity function is a bijective function, right? So keep this in mind that the identity function is a bijective function. Okay. Next type of function is a constant function. Let A and B be two sets, then the function f from, we have defined set A and B. So defined by fa is equal to b for all A in set A but for a fixed B in B. Now what does this mean? Suppose we have two sets, we have defined a function f from set A to set B, right? So it means, let's say 1 maps to y, 2 maps to y, 3 maps to y, 4 maps to y, 5 maps to y and 6 maps to y. So all this function, so fa is y for all A in set A. So each and every function maps to a fixed element in set B. So is this a 1 1 function? No, because every element in A has a unique image in B. So first thing, that it is a many one function. Is it an onto function? Check. What's the codomain? The codomain is the set B, but what will be the range? The range is just the set Y. So the range is a codomain of, range is a subset of the codomain of F, which means that it is into function. That means it is many one into function, right? So it is many one into function. So this is how we define the constant function. Next is equal function. Two functions f and g are called equal function if these two conditions are satisfied, that their domain are same and fx equals to gx for all x in the domain. Since their domain are same, you can take x in either f or in g, right? And if any one of the condition fails, then the functions will be unequal, right? So otherwise the functions are unequal. You can see one example here. We have considered a set A 0 to 2 and B 1, 2, 3, 4 and 5 given by f goes from A to B. We have defined the function fx equals to 2x plus 1 and g goes from A to B. We have defined it as x square plus 1, right? For all x belongs to the set A. So clearly you can see that the domain of f is same as the domain of g, which is the set A. Second thing, we need to check that if fx equals to gx, right? So we will check at x equals to 0. So f of 0 is, just put it, so fx is 2x plus 1. So f of 0 will be 2 times 0 plus 1, that will be 1. Similarly, g of 0 is x square plus 1, 0 square plus 1, so that will be 1. So f of 0 is same as g of 0. Similarly for f2, the same thing we can check. So 2 times 2 plus 1, that will be 4 plus 1, 5, right? Similarly for g2, so 2 square plus 1, so 5. So from here fx equals to gx for all x in A. Therefore the two conditions are satisfied. The first was the domain should be same. Second thing is fx is equal to gx for all x in A. So from here we can say that f and g are equal functions, correct? Next, the final type of function is monotonic function. What are monotonic function now? There are two types of function. One is called increasing function and one is called decreasing function, right? So if f is a real valued function, then f is called an increasing function if and only for all x1, x2 belong to the domain of f such that x1 is less than x2. This implies fx1 is less than fx2. Let's see this on a graph. You can see that I have taken x1 and x2 from here. Clearly x1 is less than x2. You can see that corresponding to x1 this is fx1 and corresponding to x2 we have fx2. Now can we compare them? Yes. We can see that fx1 is less than equal to fx2, right? So such type of functions where for all x1 is less than x2, fx1 is less than fx2, such type of functions are called increasing function, right? Similarly, what should be the condition for the decreasing function? Same, we can consider x1 less than x2. This is x1, this is x2, but check, this is fx1 and this is fx2. So clearly fx1 is greater than fx2. So whenever we have such a condition, this means that the function is decreasing, right? So whenever your function is either increasing or decreasing, such type of function is called a monotonic function, right? Such type of function is called a monotonic function. So I hope this was clear to all of you. So today we have discussed about the types of functions and we have also discussed about the domain and range of some standard functions. So in our next class we are going to define how to prove a function is 1, 1 and onto, right? Thank you for watching.